You're dead. That's what you feel like.
Okay, let's just find the mouse. Mouse of mouse. It's still recording here. What happened?
I was shooting because my hand. I shot her in the brain.
Okay. Ladies, please. Okay, question number 21. Expand and simplify. Right. Should be nice and straightforward question. Start with the y, multiply by the y multiply by minus 5. So y times by y is going to give us. Then we have y times by minus 5. That gives us minus 5y. How are you doing, Mr. Holman? Okay? You look a bit flustered today. You got minus 2 next time by y. What's minus 2 times by y? Minus 2y. We got minus 2 times by minus 5 next. That gives us what?
Minus 7 plus 10.
Wow, minus 7. Okay, if you haven't realized, you multiply them that. Okay, lovely. Let's simplify this. What do we get? So the y squared stays as y squared. This part here simplifies because they're both y terms collecting like terms. That gives us what? And that part stays the same. Plus 10. Whoops. Okay, no. That's 10. Okay, Ifra, you got that? Did we get y squared minus 7y plus 10?
Yeah.
And the answer goes here.
That's what I got.
Okay, prove algebraically that 2n plus 1 squared minus 2n plus 1 is an even number for all positive values of n. Right, now, what does that square there mean?
That is squared.
That means write the bracket out
Twice.
twice. That means times by itself. Whoops, oh, that's funny brackets. Okay, now let's multiply these brackets. So what's 2n times by 2n?
4n squared.
So let's, do we need to write this one down? Can we just say it and write down here? So 2n times by 2n will give us 4n squared. 2n times by plus 1 will give us
2n.
plus 2n, not 2n, plus 2n.
Yeah.
Plus 1 times by 2n will give us
Plus
plus 2n. Plus 1 times by plus 1 will give us plus 1. We got to say the plus because that helps us combine everything together here. And we got here minus, well, what's outside the bracket here? Minus 1. So you have to multiply this bracket out by multiplying everything by minus 1. So minus 1 times by 2n is?
Why is that you?
Is which one? That one there. That's actually an n. It's a bit.
Oh,
Sorry about that. That's my handwriting. What's minus 1 times by plus 1?
minus 1.
Minus 1. Okay. Are we happy with that so far? So what we need to do now, we need to do a cancelling. If are we doing cancelling? So plus 1 and minus 1, they cancel each other out. Okay, that's not.
This is that or windy outside.
Yeah, okay. So we got here. Okay. Cross these two out. Okay, we got plus 2n. Oh, excuse me. Sorry about that, folks. We got some software remnants. So we have plus 2n and minus 2n. They cancel each other out completely. Yeah? So what are we left with?
4n squared.
So we're left with 4n squared plus 2n. Now, if you want to factorize this, we factorize it, what will you get?
2n
So we take the 2n from each one.
and n. 2n, sorry.
Right. So how do we know? Because proof algebra says it is an even number for all positive integer values of n. Now, so this n can be, this n particular n can be odd or even. Now, so what is the proof that it's going to always be positive?
If anything times 2 is positive.
That's anything times by 2 is even. So we got to prove that it's going to be even number. So once you introduce a multiplier by 2 in the question, so in essence what we could do here, we could say this. So separate as 2 times by n times by 2n plus 1. Yeah, so whatever these numbers are here, you have a product with a 2 in it. As long as you multiply the number by 2, it will convert it with this odd or even, it will convert it back into even. So let's write that down as a comment. Okay, so we say the Okay, the 2, i.e. multiplying by 2, okay, proves, oops, okay, let's go, oh, whoa, that's funky. Okay, shows that the expression will always be an even number if we multiply any integer.
Do you have to write this?
Well, it's your lesson, isn't it? What do you think? You think I'm writing it for fun? If we multiply any integer, oh, this spelling looks horrible. Let's just try that again. Okay, and if we multiply any integer, so the integer n, if we multiply any integer by 2, we
So what does that say? That
we will always get an even number.
So what does that say? Shows that the
So the
at the top shows
the
that
2 I time by 2 shows that the expression will always be an even number. The time by 2, that's the proof. Because if we multiply any integer by 2, we will always get an even number. So it's the doubling effect that turns an odd into an even, and even as an one.
Can I figure out because even time by 2 even number? Get it?
Okay, right. Are we happy with that? Get the word now, please, quickly. You right? One word is on. Okay, we need to finish now, folks. Let's just. If you multiply any integer n by 2, we will always get an even number. If you multiply any odd number, you can say as well. Any odd number times by 2 is always an even, and an even times by 2 is always even. So the times in by 2, that fact is times by 2, that will generate even numbers. Okay, hang on a second. Let's just